Hi, my name is Jameson Berg, and I work with Dr. Vikram Deshpande on carbon nanotubes in collaboration with Oregon State University in the form of Ethan Minot's group. Carbon nanotubes are a single sheet of carbon atoms that are rolled into a tube. And the interesting thing that happens is when you apply an electrical gate underneath, it turns into a quantum dot. On the left here, you can see an SEM image from our collaborators at Oregon State University of our system. These gold pads underneath are the gating pads that will turn the carbon nanotube into a quantum dot. So what happens in a carbon nanotube is when you measure the conductance, you can see individual electrons entering into the quantum dot. This plot that I got over the summer shows this. Each one of these peaks corresponds to one entire shell, and then each peak has 4 subpeaks, each corresponding to a 4 degenerate electron system. So you have spin up, spin down, and then something called the valley degeneracies. This is one of the many regimes that carbon nanotubes can fall into, and they all expose themselves in these conductance measurements. To turn the system topological, we need to produce some sort of topological constant that will come out of these carbon nanotube systems. It has been proposed by Dr. Thallis to create something called a Thallis pump. It is very analogous to a Archimedes pump, where you turn a screw and discrete chunks of water are brought upwards. To do this in an electron system, such as carbon nanotubes, you need to apply some sort of periodic moving potential. And what this does is if you move it parallel to the carbon nanotube, then you will get quantized electron packets that move through the carbon nanotube. And these will be expressed in discrete electrons. So a very brief summary of what this project has been is a study to study correlated physics in 1 dimensions. And then we want to apply a moving periodic potential on top of the carbon nanotube to create a topological material. And this will lead to a robust dissipationless 1-dimensional system and possibly a topologically protected 1-dimensional transition. Thank you for your attention.